Hey guys, welcome to the channel. We're going to be solving question 3 from the chapter 2 of Hibbeler textbook, and we need to determine the magnitude of the resultant force Fr of these two forces F1 and F2 and its direction measured counterclockwise from the positive x-axis. So we're going to use the parallelogram law in order to find the resultant. So if you do that, we're going to draw a parallel line to each of these two forces. So one parallel to F1 and another one parallel to F2. And the point that connects the origin to here is going to be our FR. So now we can do the law of sine and cosine in one of these two triangles that we have. We can go with the top one. I'm going to highlight it in yellow. So if we want to do the law of cosine, we know we have F1 in here and our F2 would be here. So for law of cosine, we have FR squared is equal to F1 squared, which is 250 squared plus F2 squared, 375 squared minus 2 times F1, 250 times 375 times cosine of, and this is the trickiest part of this law, that the angle that we're going to pick in here is this angle right here, which is alpha. So we need to figure out the alpha. Let's see how we can find alpha. If we draw this line in here parallel to y-axis, since this angle is 30 degrees, this will be 30 degrees too. And we know this angle here is 45 degrees, which means this angle here is 45 degrees because this is going to make a right angle in here. So the angle alpha in here would be basically 45 plus 30 degrees, which is going to be 75 degrees. So here we have cosine of 75 degrees. So now we can find the magnitude of the resultant. So if we want to find FR, we basically have a square root of the right side. So the square root of 250 plus 375 minus 2 times 250 times 375 times cosine of 75 degrees. Make sure to set your calculator on degrees, and that would be the final answer for us. It's going to give us 393.19. The unit is pounds in here, so we found the FR, or the magnitude of the resultant. So now we can do the law of sine in order to find the angle that FR makes counterclockwise from the positive x-axis. So we're going to do the law of sine now. And if you want to do the law of sine, we basically have sine of alpha, or 75 degrees, over FR, which we found is 393.19, is equal to, we can call this angle theta, sine of theta over F2, which is 375. So our theta would be basically sine inverse of 375 times sine of 75 over 393.19. So we have sine inverse of 375 times sine of 75 divided by 393.19. So that's going to give us 67.1 degrees, which is the angle. So that shows that our FR is actually, because what we have in here, this is our y-axis, this is our x-axis, and we have F1 somewhere here that makes 30 degrees in here, so this angle would be 60. But the angle between FR and F1 is 67.1, so we have a little bit over, like below the x-axis, which is, we want to find in this angle would be actually 67.1 minus 60, which is 7.1 degrees. But what the question is asking is its direction measured counterclockwise from positive. So if you want to go counterclockwise, we're looking for this angle, which is basically, we can call that angle phi. So our phi would be 360 minus 7.1 degrees, and that's going to give us 352.9 degrees. So this was our FR. So yeah, that would be the final answer for this question. We are covering 3 different textbooks in this channel. Feel free to check out the playlist and let me know which textbook you want me to cover in the next videos and a specific week chapter from that textbook. You guys are more interested, then I can cover those in the next videos. You guys take care. I'll see you in the next one.